Alright, so we'll start with the graph on the next page. So what do we notice here? We notice that it tells us to sketch this graph. Okay, let's follow all the steps that we did in our previous problem. If we follow those steps, you should not have any trouble, provided you understand each of those steps. So make sure you're focusing, paying attention, and understanding each of the steps. So step number 1, remember what I said? So I've written down the steps in this little piece instead of going back and referring. So step number 1, you want to find the n behavior, and you find the n behavior of a graph by figuring out what is its degree, right? What is its degree, and whether it is positive or negative leading coefficient. Can we all take 30 seconds and write down what is the degree and is the leading coefficient positive or negative? I'm going to put it down in a few seconds, but please go ahead and take a look at what the degree is. Did everybody get this? 7th degree and positive leading coefficient. I don't see a negative in the front, so it is 7th degree and positive leading coefficient. Okay, so I've taken care of the first. Okay, so before I go to the second step, the whole idea of doing the n behavior is to know how it behaves. Where do I start my polynomial? Where do I start my polynomial? So 7th degree will behave like what? Alright guys, everybody should know this. Or even degrees behave like quadratic, odd degrees, which is this, behaves like a cubic or linear. Perfect, cubic or linear. And how does a positive linear graph behave? You're climbing up the hill. That means you will start in this quadrant and in this quadrant. Is everybody clear about this? Okay, we talked about this for a while in yesterday's class, or whatever, whenever I had you guys last time. But if you're still not sure, you should ask. I can repeat as many times, but I want to make sure you understand. Yeah, go ahead. Yeah.
I was going to ask, what is the leading coefficient again?
Whether it's positive or negative. Oh. So it's basically, I don't see. So for example, in the next problem when we go, you see a negative sign in the front.
Oh. Okay.
Yeah. So literally the highest exponent, if you expand it to the standard form, is my first one. So the first one is going to be something to the 7th power. So it could be positive 2 to the 7th power, whatever. Yeah. So it's basically literally what it says, leading coefficient. Yeah. So if it's positive and it's 7th degree, it's going to behave like a positive slope, because it's going to behave like a linear or a cubic or any of those functions. Okay. So I've taken care of this n behavior. Okay. Starts here, ends here. Step number 2, you want to list all your x-intercepts. Right. It's easy because my factors are given. And what's new is at every x-intercept, I want you to write whether it touches or crosses. Do you guys remember that? I will let you guys do the work, take a minute, try to jog your memory from what I taught you, but I will explain it also, but I need you guys to try. Okay, please take a look, and I'm going to explain it. Everybody okay? Can I explain it? Okay, so the x-intercept should be easy. That's the easy one, right? From x minus 4, you get 4, 0. From x plus 2, you get negative 2, 0. From x minus 3, you get positive 3, 0. But how does the graph behave at each of these x-intercepts? So basically, whenever the power, the exponent of the factor is even, like this square and this square, it's going to behave like a quadratic. How does a quadratic behave at an x-intercept? It touches it. This is what we, sorry, here we go. This is touching. This is touching. Because this is even, right? Square is even, square is even. Anything to the 4th power is even. Anything to the 6th power is even. Anytime you have an even exponent, it is going to touch because it's going to behave like a quadratic. Anytime you have an odd exponent like x minus 3, that is why my x-intercept 3, 0 crosses it. Why? Odd ones behave like a linear or cubic. How does a linear behave with the x-intercept? It crosses over. This is your cross. Is everybody clear? What do we mean by cross and touch? You're basically crossing or touching the x-axis because it's an x-intercept. So you are basically talking in terms of the x-intercept. Antonio, yes.
So every even number is touched.
Yes.
And odd is crossed.
Correct. Yes. And actually, if you go back a couple of pages, I have put a box and I've said x-intercepts and the behavior of the x-intercept. It clearly says. Let me quickly turn it around so I can show you where it is. So you can go back and read it if you're still not clear. This section. Page 4. This section I said behavior at x-intercept. And I've said if the 0 is even multiplicity, it touches because it's like a quadratic. If the 0 is an odd, it crosses it like this, like a cubic or linear or whatever. So it crosses over. Basically, it crosses over. Yeah? Okay, so this is there in the notes if you want to go back and read it. All right. Going back. So did everybody understand the touch, and the cross? Why each one of them is that? All right. And the last thing we do is when we wrote down our notes, we did the end behavior, which is based on the degree and the leading coefficient. We did the x-intercepts and the behavior at each x-intercept, whether it crosses or touches. The last thing I need to do is the y-intercept. How do you find the y-intercept? Anytime, algebraically. Forget that's a polynomial. Annalisa's hand is up. Anyone else? She's already given me a couple of answers. Everybody should know how to find the y-intercept. You find the y-intercept by, yeah, go ahead, Rebecca. Perfect. Why? You always solve for y-intercept by setting x to be 0 because that's what it means. Y-intercept means it goes to the y-axis. At y-axis, x equals to 0. So what you're going to do is you're going to take a polynomial. Okay, you're going to take a polynomial and this polynomial you're going to set x to be 0. So let's all do that. 0 minus 4 is just negative 4 squared. You're basically solving for y given x equals to 0. That's what it means. 0 plus 2 is 2. 0 minus 3 is negative 3 cubed. You might need a calculator for this. It is large numbers. We'll make sure we don't give you large numbers if it's on a quiz. If you're not letting me use the calculator, but go ahead and use the calculator at this.
576.
You got how much?
576.
What did I get? I got 1728. Okay, let's see. Let me write this down. So negative 4 squared is positive 16. 2 squared is 4 and negative 3 cubed is negative 27. You put 9? By mistake, yeah, okay. And it will be negative, guys. That's what's important. That way you know that it's going below the x-axis. It's touching the y-axis on the negative side. Alright. And I got negative 1728. It is a large number. So my y-intercept, I'm going to go ahead and write it. Remember, one more thing, every time you write the y-intercept, it should be written as a coordinate. So it's 0, negative 1728. If you don't put the 0, I am taking half points off because you're not telling me that it's a coordinate. You're just giving me some number. So it has to be in the right format. Alright, now I'm ready. I've done all 3 steps. This is enough for me to be able to graph. So let's go ahead and graph this. So I already have my end behavior, so I know it will start from this quadrant, but more importantly, let's mark the x-intercepts. 4, 0. 1, 2, 3, 4. So this is 4 and it will touch. I'm just going to write t so that when I'm graphing it's easy for me. Negative 2, negative 1, negative 2 is also touch. Everybody okay? Everybody can see? And 3, positive 3 is cross. I'm going to write it above so positive 3 is cross. And then my y-intercept is going to be somewhere here. I don't know where. It's going to be way below, but doesn't matter. For now, we'll just take this as on the negative y-axis where we can see. So these are things that I've marked. And it will start from this quadrant, end in this quadrant. Okay. can we all try to sketch? Because sometimes I feel students are able to put this information and then they're not sure how to sketch. Can we all just take a shot at sketch? Use a pencil, so if you have to erase, you erase. Just take a shot at trying to sketch this, connecting all these points. All right, those who are done, that's great. Those who are not sure, I'm going to go ahead and show it. So if you want to just watch me, you can. So remember, you're starting from this point, because this is the starting behavior, and then you're going to go to the first x-intercept. So this is my first x-intercept, but think ahead. When you go to it, you want to turn around because it touches it. So you go to this and you turn around because it touches it. That's what touch means. And then where is it going to go? My next intercept is only across the y-axis. So it has to cross the y-axis, right? And it will go below, because my y-intercept is negative, so it will go below, touch the y-intercept. In reality, it will go way below, but we don't have that space. It will go below, touch the y-intercept, and then where will it go next? It will go to the next x-intercept. At the next x-intercept, it is going to cross over. It is going to cross over. The only thing I request is when you're just crossing over, there is a difference between linear and cubic. This one is cubic. So you want to give that little bit of inflection. Cubic is a little curved. So just that little bit of inflection. Am I going to take points off? Maybe really little, maybe like a 0.5, but I would like to see this inflection. Just let me know that you understand it's cubic. And then you want to go to the next. Everybody okay so far? And then you want to go to the next. So it crosses over because this 3 is cross. And then it goes to the next intercept. It has to turn around to come to the next intercept. So it turns around, and at 4 it touches again. Touch means what? Touch and turn. Touch always means it has to touch and turn. And we are in the right quadrant. We ended in the right quadrant. So this is how my graph looks. I don't know what this is. I don't know what I did. But this is how my graph looks like. Starts here, -2 touches. Touches always means it turns around. Touch always means it turns around. Crosses the y-axis. Goes to the next intercept. Next intercept it crosses. Goes to the next x-intercept. It touches and ends in the quadrant that it should. Is everybody okay? We got the graphing. Okay. Can we all fill in the three things we haven't filled in is we haven't filled in the 2 limits as well as the maximum number of turning points. I'll give you guys 1 minute to fill up these 3 and then I'll explain it. Yeah. Okay, I'm going to go ahead and explain it. My limit is positive infinity and negative infinity. Why? As x is going towards infinity, right, my graph is going up. And as x is going towards negative infinity, my graph is going down to negative infinity. Everybody okay with the limit? And then the last one I said maximum number of turning points, you just use the formula. Remember that it's degree minus 1. Any graph, the number of turns is always going to be degree minus 1. We don't really use this in our pre-calculus, but it gets useful when you do things like a little more advanced math. It gets a little more useful.